Okay, so very first thing with 1.4 is we're talking about slope, and let's get your definition here. That when you talk about slope, that is your m value, and m to me stands for movement. That may not be technically what it's supposed to be, but they always tell you that slope is m. So let's just say it's the move, because that's really what it is. It's the movement of the line. How does the line move? And you've got two different formulas. Because this is the standard formula that they've always given to you time after time after time, where it's the changes in the two y values over the changes in the x values. Call me crazy, but here's what I like to do. I like putting the first thing first and the second thing second. So if you want to use that one, you can, because you get exactly the same answer. Because I've seen people that would mess this up first because they focus so much on where things go that I'm like, oh, let's just put the first thing first and the second thing second. They're like, why would I do that? I'm like, because it's easier. So, I know that sometimes they give you this formula and it's there because of a certain reason, but 9 times out of 10, it's easier to go with this one because you're putting the first thing first and second thing second. Just makes more sense when you go through those. Okay, and what they'll do is now, before we do that one, just remember, you've got basics on these. That when you talk about lines, that slope is always measured to the right as you're going through these, because they had to have somebody had to set it this way. I did this one time with, I think it was a Algebra 1 class. We were talking about this. I just threw that line up on the board and I said, all right, which way is this line going, up or down? All my right-handed people said the line's going up. What did all my left-handed people say? Said down, right? Because they're thinking left-handed. They're over here because their dominant hand. They're over here. They look at it and they go, "It's going down." I'm like, and I asked them. I said, "Why are y'all saying it's going down?" They're like, "Well, I'm looking at the left-hand side." And I was like, "Why is that?" They said, "Because I'm left-handed." And I was like, "Okay, makes sense." So somebody had to set the rules of whether this thing is positive or negative. So somebody finally said, "Okay, the right-handed win because there's more right-handed people. So this line is going to be positive." If you're going this way, that's negative. If it's a horizontal line, it's not positive, it's not negative, right? It's in the middle. So it's horizontal. Now, and for the longest, I used to screw these up because I never could. I memorized the lines. I didn't learn them. I just memorized them, got through the test, and I was gone. Can't really do that when you're teaching because, you're teaching it all the time. I finally had to memorize a trick on this one because it's horizontal, but it doesn't, the value when it comes down to it is this. And here's the trick I figured out on this one. This one has a 0 slope. And the only way I remembered this one was the z in horizontal matched up with the z in 0. So if you have a horizontal line, it has a 0 slope. If you have a vertical line, it's not a 0 slope. This one is an undefined slope. And we'll come back and talk about why that is here in just a second with the difference of the two there. And the one thing that somebody told me one time that, again, another teacher told them this. I said, basically, you're rolling the ball. And what happens when you roll a ball? To the right on this one. Well, if you start over here and roll the ball, it's going up the hill, so it's positive. Start over here and roll the ball, it's going down the hill, it's negative. This one, it doesn't go up or down, it stays the same. So it didn't change. The altitude stayed the same. It's zero change. And this one, can you roll a ball on a vertical wall? Bounce it off of it, right? But, we're not talking about a sticky ball where you throw it up and it just, does a Spider-Man thing where it falls down the wall. You can't roll a ball on a vertical wall, so if it's not possible, then it means it's no slope or it's undefined. So that's kind of the way those go with that. But where they tie in with that one is they're going to give you some points of a line and say, okay, here's 2 points on the line. Tell me if it's positive. Tell me if it's negative. Just tell me what the slope is first, and let's go from there. Oh, here's a nice spot here. Okay, so there's your 2 points. Negative 2, 1, 3, 6, and they'll tell you find the slope of this one. And the easiest thing in the world to do to make sure you get the right problem is write down what those numbers are. That's the first order pair, so that's x1 and y1. I've seen people that would put that this is x1 and x2, and I'm like, no, it's the first order pair. Everything's got to be 1s on this one. When you get the second order pair, make sure it's x2 and y2. Okay, and from there, it doesn't matter which formula you go with. I'm going to go with first thing first, second thing second, just because to me that one, in my mind, that's where I make fewer mistakes if I do it that way, putting the first thing first. The only thing is you have to put the y's on top, so that's 1 minus 6 on top. On the bottom, it's negative 2 minus 3. 1 minus 6 is negative 5. Negative 2 minus 3, also negative 5. If you have negative 5 over negative 5, that means the slope is 1. There you go. Sure, go for it.
So you have a slope of 1 that both, let's say you just have the slope and you didn't have a slope here.
Mm-hmm. Well, yeah, basically if it's a whole number, you can always put that number over 1. So from that one, that means you're going up 1 and then you're going to the right 1. So that, and to me, that's the movement part, is that it tells you how to move to get from one point to the next point there. To me, that's where the M is always kind of come in on this thing. So. Yeah. Yeah, and that's one we'll do next year. Yep. Yeah. No, you're good. So yeah, let's say we had like 8, 8, 5 for the next point there. Okay, and again, let's keep it simple. You know, when you're doing these, make sure x1 and y1 on the first point, x2 and y2 on the second point. And again, I'm going to go back to this formula because I like putting the first things first and the second things second. So on the first ones, we need y2 on top, or y1 first, and y2 there is next. So it's negative 2 minus 5. On the bottom, it's 4 minus 8. So negative 7 over negative 4. The two negatives will cancel and make it just 7 over 4. So there's one where. Now, the only thing you have to do is kind of like we did on the earlier problem. Leave it improper. Leave it 7 over 4. That's good because that tells you you've got to go up 7 and right 4. But the only thing you have to do is if you have a fraction that's here, it's got to be in simplest form. You've got to simplify it down as much as you possibly can. You know, if this had been, 7 over 14, then you'd have to simplify that down to make it 1/2. So you've got to simplify it down as much as you can. It's probably one of those, if you put it to 714 and in the homework, they'll say, you've got the right numbers, but you've got to simplify it a little bit more. And they've gotten good with the homework of giving you hints along the way of saying, well, you're close, but you might want to do this, where used to it was just wrong. They didn't give you hints. Now it's a smart enough system where they've kind of started to adapt to it to tell you, all right, you're close, but you've got to go just a little bit farther there. Go for it.
Let's say you have two numbers that are the same,
Mm-hmm.
but one of them is negative, like negative 2 or regular 2.
Right.
Simplify that to be negative 1.
Mm-hmm. Now, and if the fraction is negative 2/3, they should take that answer one of 3 different ways. They should either let you put the negative out front, then you put the fraction. You can also put negative 2 over 3. You can also put 2 over negative 3. So for theirs, is as long as you've got a negative in the right numbers, where you put the negative doesn't matter. I mean, technically, they probably like for it to be this way that you've got the negative out front, or this way. Those two are the best ones. This one is still correct, but it's just sometimes a little confusing by being on the bottom. Because the bottom number should be how much you move to the right, and it shouldn't be negative because then you're going backwards. So they always try to take the negative and put it with the top number to let you know that's your up or down movement when you look at it there. Mm-hmm. No, only the top number. Because if they're both negative, the two negatives would cancel and make it a positive. Kind of like if you go back up here to this earlier example that we had right there. We had a negative and a negative. Well, the two negatives will cancel and make it a positive. So if you had to write it on a graph and movement, you're technically going with both of them positive 1 over 1. If it was a negative, let's say it was negative 1. When you do that slope, it would be negative 1 over 1. Regardless of what the number is, if you need to make it a fraction, that number will stay the same, and you just put a regular 1 underneath it to get what you need there. Okay. Okay, we'll do a couple more of these and we'll wrap it up here. So we got 7, as far as finding the different slopes here. 7, 3, and 6, 3. Again, easy thing to do is go back and just put your x1s and y1s in there. If we plug it in again, first thing first, it's 3 minus 3 on top. On the bottom, it's 7 minus 6. It's a 0 over 1. Okay, now, does everybody have a calculator with you? Punch 0 over 1 in your calculator. That's going to tell you that the answer is 0. And if that's 0, that means that when you graph this thing, it's a horizontal line. All right, let me give you one more of those, because the next one will kind of go the difference of these two that you have here. All right, give you one with double negatives here, because we didn't look at one where we had two negatives on part of it here. Okay, so 8, negative 4, and then 8, negative 10. So again, there's your x1, y1, x2, y2. And again, I always do that one, but the reason I go with that one is the first numbers have to go first, the y's are on top, so it's negative 4 minus. Now, here's one thing I would say. Anytime you plug in a negative number, put that number in parentheses. Because that should take, and especially if you're using the Casio, even the Texas Instruments calculator, if you got either one of those two, punch that in, it'll do the work for you. On the bottom, they're both positive, so it's just 8 minus 8. If you do negative 4 minus negative 10, that's negative 4 plus 10 over 0. And then negative 4 plus 10 is 6 over 0. Okay, now, and if you don't have this memorized on your calculator, if you punch in, if you get to the test and you're not sure which one's which, just punch the number in your calculator. If you punch in 6 over 0, it's going to tell you an error message, probably. And if it's an error message, that means that it's undefined. Which means it won't be the horizontal line, this one's going to be a vertical line. And I used to struggle with those all the time about which one was 0, which one was undefined. Went all through high school, and I never figured it out until I got to college sometime, and I was like, I'm an idiot, because I had the answer in my hand the whole time. All I had to do was just punch in my calculator. Even the little cheap, crappy 4-function calculators, if you do 4 divided by 0, it's going to put an error message on your screen to let you know, hey, you can't do that, which means it's not a 0 answer, it's an undefined answer, which means it's not possible. There is no slope of that line, because it's a vertical line when you're going through that. Okay, so that's where that's them just practicing, giving you all the different options on this. Once they've gone through and done just the slope, the next thing they're going to roll through is they're going to give you some different forms. They start talking about the different types of forms you can work on these. And really the two main forms you're going to look at is you're going to have point slope and slope intercept. And the first one, point slope form, to me, I always add a little bit extra to it. Really, it's point slope. I call it the formula, because this is the one if you're not sure what to do, this is the one you always go back to. Because there's always going to be those Well, there's going to be one problem, hopefully maybe not more than that. There'll be a couple times where you're going to get a problem and you're going to look at it and you go, I don't know what to do. If you get to a problem and you don't know what to do when they ask you to find and write it, do whatever, always come back to this one. This one you can always get to the other form, which is slope-intercept. You can get from here to here pretty easily. Getting from here to here is almost impossible, because there's more information here than what you need really when it comes down to it. So this is one of those that if you're not really sure what to do, sometimes starting here you may get part of it and you get there and you go, what else do I do? I don't have everything I need. Where if you start with this one, you'll have everything you need. You just might have to rearrange it a little bit. So whenever you get stuck, if you're not sure what to do, always start with this one, and eventually you can take this and rewrite it here. And that's really what we're going to do on the problems we're going to do. We're going to start here every single time and get this answer, and then we'll change it to go to this answer, because that's about half of the work you have to do is being able to convert from this one to this one and go through the parts over here. Okay, so here's what we'll do. We'll just run through some different examples. Now, the one thing you have to know for this one is, of course, M is your slope. On either one of these two problems you're going to do. For this one, the B is your y-intercept. And when we start graphing these in just a little bit, we'll come back to that a little bit more. But the M that stands for your slope, that's your movement, how to get from one point to the next point. The B, that's your beginning value. That's where you would start for this thing. And I've actually seen people, and I've thought of this for years, that you start the B, I don't know if we'll ever get to the point where we do this, but to me that would make sense to do it this way. Do B plus MX, because you start with this number. That's the beginning part. And then you move with this number. Now, I don't know if we'd ever eventually get to where we do it that way, but we've been working to try to get to the metric system for 40 years now. I mean, we're closer to it. About as close as we can get to having a liter bottle instead of a quart bottle. Okay, so here we go. We're going to take this one line that we have, we're going to write it in point slope and slope intercept form. And we've got one at the end where we'll talk about standard form, which you'll see a little bit of it, but it's really not that much. These are the two main ones that we'll get to here. Okay, hang on, let me check that out. That's our directions, and we'll do the examples from here. Okay, for this one, our slope is -3, and we're going to have a point on the line that's at -2, -3. Okay, and again, back to the KISS method here. Let's keep it simple. Slope is -3, so that tells you that your M value is -3. This is the first point they give you, so this is x1 and y1. Again, don't overthink some of the problems, because they make it pretty much what it is there. Once you've got these two numbers, we're going to plug it back into point slope. So that's y minus y1 equals m times x minus x1. So plugging those values in, it's y minus y1 is -3. M value is also -3. And our x value is -2. Okay, and the only thing you do to get the answer for part A is you clean up the double negative that you have. You've got a minus negative here, So make that y plus 3. This negative 3 is okay. You've got another minus negative here, so make that x plus 2. And that's all you do for part A. Now, I know some people look at that and they go, oh, but you got so much. That's the B part. That's the next thing we do. For part A, that's it. The only thing you have to do is if you have a minus and negative, either here or here, when you plug in the x1 and the y1, make those positive. That's your answer for part A. Okay, part B then is we're going to take this equation we've got here and we're going to rewrite it so it's in slope-intercept form. So let's take that to the next page. Okay, so that was our answer from part A. Part B then is we're going to do two things. You're going to do distributive property with a negative 3. And whatever this value is, it's over here on the right hand or on the left hand side, you're going to add or subtract that number away to the right hand side, and then that will be your answer. And there's your B part. Negative 6 minus 3, which will get you a negative 9. And to get, once you've got part A, which again, there's not really much you can do on part A. You just plug it in. Again, you fix a couple of negatives. It's going to be the same two things every time. You're going to do distributive property with whatever number you have here, and then you're either going to add or subtract away this number, combine your like terms here, and then that's the answer you're going to have. So it's going to be that same pattern every single time. Now, the numbers will change, of course, but it's that same two steps every single time to get from the part A answer to the part B answer. Let's do one more with the slope here. So slope at negative 2/3 and passing through the point at 6, negative 2. So that's your m value at negative 2/3. And again, I cannot draw that. There we go. And again, that is your point at x1, y1. So for part A, it is y minus y1 equals m times x minus x1. Again, and this one, there's only one thing to do for this one. We have the minus negative here to make that a plus. And that is your part A answer. And if you don't have, and some people always ask, what if I don't have a minus and negative? Well, once you plug the numbers in, that's it, you're done. You don't actually have to do anything other than plug the numbers in. For the part B, here's where you get to do the work. That again, you're going to do negative 2/3 times x, and then negative 2/3 times negative 6. So this one is still negative 2/3 x. Now for this one, make sure you do a negative times negative, make that a positive. When you do 2/3 times 6, remember that 6 is over 1. So if you're multiplying that part out, you can either cross cancel, or if you multiply straight across, that's 12 divided by 3, which would be 4. And then the last thing on this one is, because it's a plus 2, subtract 2 off both sides. Y would equal negative 2/3 x plus 2. Sure. How far? Oh. Yep. Yeah, that's the big thing for that one is that you've got to watch, yeah, because you're doing negative 2/3 times negative 6. Yeah, so that does make that a positive. That's usually the part that kind of sneaks up on you. It's those simple little things that get you sometimes. Okay. All right, example 3. They changed things up a little bit. That instead of giving you the slope in this case, they're just going to give you 2 points. So, okay, here's 2 points. Tell me what the slope, what this equals. And again, we'll do both. We'll do the point slope and the slope intercept. Okay, difference on this one is you don't have the slope, but you do have that this is the first point, so that's x1, y1. That's the second point, that's x2 and y2. And the one thing you've got to kind of realize, whether we're in section 4 or 5 or section, they won't do it for section 6, but anytime in 4 and 5, if you're given 2 points, find the slope. That you can pretty much guarantee that anytime in sections 4 or 5, they give you 2 points, you've got to find the slope. I mean, that's pretty much a given. So before you do anything on this one, go ahead and just run through and get the slope here, which again is your m value. So we're going to need y1 minus y2 over x1 minus x2. So it's a negative 8 over negative 6. 2 negatives will make that positive. And if you have 8 over 6, you can divide them both by 2. So your slope value would be 4/3. Okay, once you've got the slope value, now that you have the m value, now you can take this m value, take that x1 and y1, and now you can go back and plug that back into the formula. So we have y minus negative 2 equals 4/3 times x minus negative 3. What's negative 3? Yeah. Okay. And again, there's only one thing you can do for part A, is where you have a minus and negative, go back and make those pluses. Now, your other option you could do, if you want to do this, if you want to get graph paper, put those 2 points on there, and then just make a right angle between those 2 points and count how much up and how much over you go, or how much down and how much over you go. You could do that. You know, if you want to just graph some points on graph paper, you could do that to find the slope. Which, again, you basically, if you're going from this point to this point, you would go up 8 and over 6, so then you'd have the 8 over 6 and simplify and make it 4/3. You could put on graph paper and do it that way, but they're always going to show you the mathematical way of going back and finding that one. And then part B, same thing as before. We're going to do distributive property. So that's 4/3 x. And when you do 4/3 times 3, well, in that case, your 3's cancel. So that's 4 over 1, or just 4. And the last thing on that one, again, is get rid of that 2 and move to the other side. And they'll give you all kinds of different things on these to look at doing. But they'll just give you a variety of different options to throw out. But it should always kind of go back to that same thing of find the first one. Once you've got it written the first way, then just rearrange it, do a little distributive property to get to the second form that you're looking at. Okay, and then the last thing in section 4 that'll kind of roll us into section 5 is they're going to ask you to start graphing some different things. do so good, and I get so bad there at the end. Tell what the slope and y-intercepts are. And then they're going to ask you to graph. Okay, so you got y equals negative 2x plus 1. So your slope is your m value. In that case, it's negative 2. Your b value is positive 1. In that case, you can just put 1. And again, the b value, when you talk about these, that's where you begin. So I always like for something to actually make sense why they called something what it was. So the b is begin here on the y-axis. The m is tells you how to move to get to the next point. Okay, and so quick sketch on these. So we're starting at 1. That's right there. And the only thing with your slope is, even though it's negative 2, when you start to graph it, again, it's got to be a fraction. So really it's negative 2 over 1, which means we're going negative, meaning where we're going down. The bottom number is always your right-hand movement, how much you have to move to the right side. So for this one, we're going to go down 2 and then over 1 to get to the next point. And when you're graphing these, you'll just have to play around online because they have a drawing tool that will come back in and automatically draw that line for you, so it looks something like that. Oh, the b value? That's where you start on the y-axis. Mm-hmm. Yeah, so whatever the b value is, that's always your starting point on the y-axis. And so, why doesn't it on the x-axis? Well, you've got x and y, and b is the second letter in the alphabet, so a should go with the x-axis and b goes with the y-axis. Again, just trying to make it make sense. I don't know if that's really true or not, but that's what we go with. And at least in my mind, anyway. Okay, so for this one, let's go 3/5 x minus 4. So your m is 3/5, your b is negative 4. So when you start to graph this one, a little bit more room at the bottom there. Okay, so again, with the b value negative 4, we're going to start at negative 4, which would be right there. And from that point, you're going to go up 3, so up 1, 2, 3, and over 1, 2, 3, 4. Oh, need one more there, which would be right there. So again, you're going to go 3 spaces up, starting at negative 4, you go 3 spaces up, 5 spaces over, and put your next dot. And once you've got that dot, then you can just connect the dots together. And the line will look something like that. Yeah, if it was just, if that was just x, then yeah, that would be still a 1 there. So it'd be 1 over 1. So at that point, you would go up 1 over 1, put the next dot right there. Okay, the only other, and just give you these real quick, the only other thing they'll do at the end of section 4, they kind of give you a couple of trick questions. And I'll tell you, all right, now this one, not necessarily so much of don't tell me where it is, this one, just going to graph it. Don't tell me what the slope is, don't tell me what the intercept is, this one we're just going to graph it. And here's what you got to kind of realize. On the other ones we had X's and Y's, so there's always some tilt to it. If there's only one letter, it only goes one direction. It's either vertical or it's horizontal, and you just got to figure out which one it is. Now, here's what, and I'm going back in my time where I used to mess these up. Here's what you got to realize is that for this graph, and this is what I had a teacher one time that told me when I got through this one. He said, well, all right, let's just get back to the keep it simple method. You can pick any point you want to pick, but the y value is always 3. So he said, pick 2 points where the y value is always 3. He said, make it easy. I was like, well, let me graph the point 1, 3. Let me graph the point 2, 3. He said, all right, go graph those 2 points and see what you get. So the point 1, 3, I'm going to go over 1, up 3. Next point is 2, 3. Connect the dots. There you go. There's your graph. So when you're, and again, I'm not going to tell you how I used to think, because I always got these messed up. I'm not going to tell you because, you know, sometimes you tell people how to do the wrong thing, and that's what people do. And real quick, let's do this one. If it was x equals, same thing, right? Give me any 2 points you want. The x value has to be negative 4. You pick any number you want for the y values. 1, 2. So go to negative 4, 1, negative 4, 2. Connect your dots, and you've got the graph line. So when they give you these, don't put too much thought process into it. Don't try to overthink them. Just do the simple things. You know what the y value is. You put any number you want to for x. It doesn't matter, but the y value is always 3. Or in this case, the x value is always negative 4. You put in any number you want to. And once you do a couple of them, you start to realize real quick, okay, if it's y equals, it's always going to be a horizontal line. If it's x equals, it's always going to be a vertical line. And then you got what you need there. So, okay, and then the last thing is they're going to ask you to graph using just the x or y intercepts. And I think we talked about this last time. X and Y intercepts. We did, didn't we? Or not? Maybe. If we didn't, we'll do it real quick. For the x intercept, you do one simple thing. You plug in y equals 0. And for the y intercept, you plug in x equals 0. Now, and those are 2 separate points, so when you do this, you can almost put a line right down the middle of it. Do one, give me one answer. Do one, give me the other answer. And you've got what you need there. So let's go with 6x minus 2y minus 12 equals 0. Okay, so for the x-intercept, which again is you're going to plug in the y value of 0, and then just work it out. See what you can do from there. So if you plug in y for 0, that's 6x minus 2 times 0 minus 12 equals 0. That'll go away. The y value goes away. Basically, that's 0, so that's out. So that's 6x minus 12 equals 0. Just move the 12 over. And then divide by 6, so you get x equals 2. Now, the one thing they may have you do in this case, instead of just leaving it as that value, they'll probably have you write that as an ordered pair. So that would be at 2, 0, because we plugged in the y value of 0. So that was kind of the given part when you do go through that part of it. For the y-intercept, exact same setup, but this time you're going to plug in x equals 0. So now we're going to have 6 times 0 minus 2y minus 12 equals 0. Again, that part will go to 0, so that part's going away. You're left with negative 2y minus 12 equals 0. Add the 12 back over. Divide by the negative 2, so your y value would be at negative 6. Now, and more than likely in that case, if they're going to have you do it by the x and y intercepts, they should ask for those 2 as ordered pairs. If not, it gets a little bit... Sometimes people get the answers, but then the graph looks a little bit... They make it too simple when they go... Sometimes they do too much when they go through this one. Once you've got those 2 values, you just plug those 2 points in. This is at 2, 0. This one's at 0, negative 6. Connect your 2 points, and then draw the line through them, and then you're good to go. Okay. Now, the biggest reason they do that is that they're going to give you answers that come out that you're going to get one nice number on the x-axis with no fractions, no decimals. You get another nice number on the y-axis, no fractions, no decimals. So that you get 2 answers that are really easy to graph, and you just plug them in, and then you're good to go. You don't have to do it that way, but a lot of times they may specifically say, when you graph this, graph one point using the x-intercept and graph the other point using the y-intercept. And I think you have to point blank specific, use those 2 points. If you don't, even though the graph may be correct, if you use different points, they make you plot those 2 points. But it's just another way of kind of looking at a graph and giving you an option of what you can do there.